Hi everyone. So in this video, we're going to continue to talk about angles and mostly focusing on angles that are measured in radians and kind of getting a little bit more comfortable with working with radians. But before we get into that, I want to tell you about a different way that we're going to be drawing angles in this video and then really in the majority of this class. So in our last video, when we sketched an angle, we would just kind of sketch the initial side and then the terminal side, and it would just be this kind of freestanding thing just kind of floating there on the page. So what we'll see in this video, and honestly for the majority of the quarter, is that we're going to instead choose to draw our angles in the context of the XY coordinate plane. And that just kind of gives us a nice way to be able to compare angles and have everything kind of standardized. And so this is what's called standard position for an angle. So let me just kind of write some of that down. So from here on, we will mostly be drawing our angles on the XY plane in what is called standard position. And I'll expand a little bit on what standard position means in a moment. So basically, standard position means that we will choose to draw our angle so that the initial side lies along the positive x-axis. So an angle, let me make this thinner. An angle is in standard position if its initial side lies along the positive, lies along the positive x-axis, and its vertex is at 0, 0. And so when I say vertex, that's like the place where the initial and the terminal sides meet. So basically, the initial side, the vertex is here, the initial side is here along the positive x-axis, but that means that we don't really need to draw those things. We no longer need to draw the initial side and the vertex because it's just kind of understood that the initial side and the vertex occur at the along the x-axis and at the origin. And so what we can do instead is just draw the terminal side. So for example, this could be what an angle looked like in standard position, and this would be referring to this angle here, for example. So that's an example of an angle in standard position. Okay, so what I would like you to do is pause the video and sketch the angles pi over 6 and negative pi over 3. So those are angles, remember, measured in radians. Sketch those in standard position. So you're going to want to probably convert those to degrees unless you're already super familiar with radians, and then go ahead and sketch them. Okay, so pi over 6. So this is something we'll be talking a lot more about in this video, but oftentimes with angles that are measured in radians, we learn this kind of conversion method that we can use, but a lot of them you don't actually have to do that full conversion. So for example, pi over 6, well, that is just pi divided by 6, right? And so we know that pi represents 180 degrees. And so what is 180 degrees divided by 6? Well, that's 30 degrees, right? So pi over 6 would be the same as 30 degrees. And so if we wanted to sketch this angle, we would just go, we talked about in our last video how 30 is 1/3 of 90. So it should look something like this. And we would just say, okay, here's our angle. This is pi over 6 radians. That's it. Okay, next we have negative pi over 3. So similarly with this one, again, you could use the conversion that we learned about in our last video, but this is one that you don't really have to do that because, so forgetting about the negative sign for a second, pi over 3, well, that means that we're taking pi and dividing it by 3. So pi is equal to 180 degrees. So what is pi, or what is 180 degrees over 3? Well, that's 60 degrees. So negative pi over 3 would be negative 60. And so remember, negative angles are measured rather than moving counterclockwise. So in our first example, we drew our initial side so that we had rotated 30 degrees counterclockwise, or sorry, we drew our terminal side so that we had rotated 30 degrees from the x-axis in the counterclockwise direction. This time we want to rotate 60 degrees, but we want to go in the clockwise direction. And so that's going to end up looking something like this. So this would be our angle of negative pi over 3 radians. Okay, so as I mentioned, one of my major goals for this video is this idea of becoming fluent in radians. So what do I mean when I say fluent? Well, think about when you're learning a new language. So when you learn a new language, you typically have to kind of look things up constantly, right? You see a word in your new language and you have to look it up or kind of translate it in your head back to your native language. And it kind of takes a little bit more time, right? It's a little clunkier. Once you become fluent, you'll hear a word in the other language and you won't really have to go through that kind of translation process in your brain as much, right? Or maybe you do, but maybe it's really quick. And so what I would like for you to be able to do, probably not today, but at some point in this class, to get to the point with radians so that when you see an angle measured in radians, you're not always having to convert it into degrees, that you can just kind of see the angle and be like, oh, I know what that looks like. So in our last video, we talked about, and I mentioned this again in this video, so we learned this like conversion factor, right? So we learned that if you want to go from degrees to radians, you can multiply by pi over 180. And if you want to go from radians to degrees, you can multiply by 180 over pi. And that always works. And that's kind of a good fallback method to have. And especially if you're working with angles that are not very nice angles, you can always use these methods. But there's kind of a better approach that I want to focus on in this video. So I want to start by looking at some very important angles, and we're going to kind of think of these as our building blocks. So these are the angles that we'll use to kind of build up other angles in radians. Okay, so 30 degrees, so I want to basically just convert each of these into radians. So 30 degrees we already talked about earlier in this video, right? This is equal to pi over 6 radians. So how do I know that? Well, you could use the conversion, right? You could multiply 30 degrees by pi over 180 degrees and cancel out the degrees and simplify. But I think the better way to think about it is that 30 degrees is 1/6 of 180, right? And so what if 30 is 1/6 of 180 and pi is our way of saying 180 in radians, well, that should be pi divided by 6 radians, right? And maybe let me draw this fraction sideways because I think I might run out of space or get cramped if I write it vertically. Does that make sense? So 180 cut into 6 pieces is the same as 30 degrees, and so that's the same as pi divided by 6. So I'd like you to pause the video and see if you can just kind of come up with the remaining angles here, just sort of not using a conversion factor, just kind of thinking through what are these in terms of 180, knowing that 180 is equal to pi. Okay, so 60, we already talked about this one as well, right? So 60 is 1/3 of 180, right? And so 1/3 of 180 would mean that it's pi divided by 3. 90 degrees, that is 1/2 of 180, right? And so that would be 1/2 of pi, so pi over 2. And then 180, well, that's kind of the easiest one, right? We already know that's pi. That's basically if there's nothing else you remember about radians, that is the one to remember, right? That pi is 180. If you know that, you can always kind of come up with these other ones from that one. And then 360, well, that's 2 times 180, right? It's twice 180, and so that would be equal to 2 pi radians. So, in I think our first video of the quarter, I said that the most important thing in that first video was those special right triangles. So that is really, really important. The 2 special right triangles that I circled like in orange. I'd say that in this video, this is probably the most important thing. Like, if you can just kind of know these angles really quickly, and then follow along with the process that we'll go over in a moment about how to kind of put these pieces together, you will be on your way to being pretty fluent with radians, which will just serve you so well in this class. I've seen so many students who otherwise kind of understand all the concepts, just really struggling with this class because they're just not comfortable working with radians. They're converting everything back to degrees and then back to radians. It's just too much. You really want to get to the point where radians feel like natural to you. Again, I know you're not going to feel like that right now because we just learned it, but just kind of keep that in mind as your goal. Okay, so I want to now go through kind of a different method for converting angles to degrees from radians and then sketching them in standard position. So again, eventually I would like you to get to the point where you don't even have to actually convert these to degrees, but this other method of converting them to degrees, I think will kind of translate a little better to this idea of fluency. Okay, so our first angle is 5 pi over 6. So old method that we learned in the last video would be to multiply it by 180 degrees over pi, right? And that would work. But here's the method that I kind of prefer for thinking about an angle like this. So what's another way of writing 5 pi over 6? Well, 5 pi over 6 is really the same thing as 5 times pi over 6. Right? Like when you multiply a fraction with a number, that multiplies the numerator. So personally, if I see in radians 5 pi over 6, I actually read it in my head as, oh, that's 5 times pi over 6. So why is that a useful way of reading it? Well, we know what pi over 6 is, right? We know that pi over 6 is 30 degrees, and that's why it's so important to know these building blocks. So because pi over 6 is 30, well, that means that 5 pi over 6 is just going to be 5 times 30. And what is 5 times 30? That's 150 degrees. And then you can go and graph 150 degrees, but you can even use this idea here of 5 times pi over 6 to help you graph the angle in standard position. So 5 times pi over 6, we know that pi over 6 is 30, right? We know what that looks like. We know that 30 degrees looks something like this. So that would be if it was 1 times pi over 6. If it was 2 times pi over 6, well, that's the same as pi over 3, but that would be like this. If it was 3 times pi over 6, that would be like pi over 2 or 90 degrees. If it was 4 times pi over 6, that would be here. And so 5 times pi over 6 is going to put us here, right? So this would be pi over 6. This is 2 times pi over 6, 3 times pi over 6, 4 times pi over 6, 5 times pi over 6. So that's how I like to think about these angles. Again, like we converted it to 150, so you could also just kind of think in your head, okay, what does 150 look like? But if you can understand it as 5 times pi over 6, you never even have to translate it into degrees. You can just kind of think of it as 5 copies of pi over 6 and use that to graph it. And so what does this angle end up looking like? Well, we don't need all these other ones. Those were just to kind of help us. So 5 pi over 6 would just be this angle that we're left with here. So I'm just going to redraw that one. So this would be 5 pi over 6. It would be this angle here. I want to mention one other kind of method of thinking about this. So I think this is kind of the easier method, is thinking of it as 5 copies of pi over 6. Another method that I sometimes like to think about is instead of thinking of 5 pi over 6 as 5 times pi over 6, you can think of it as being like 5/6 of pi, right? 5/6 of pi. And so that means it's a little bit less than pi, right? It's like, when you take 5/6 or 3/4 or 1/2 or any kind of fraction that's smaller than 1 of a number, it's less than 1 of that number. So this already tells us that our angle is less than 180, right? It's 5/6 of 180. And then additionally, we get a little bit more specific here. So 5 pi over 6, that would be the same thing as pi minus pi over 6. So where am I coming up with that? Well, pi is the same as 6 pi over 6, right? If you were to make a common denominator, pi would be 6 pi over 6. And 6 pi over 6 minus pi over 6, that's 5 pi over 6. So how is this helpful? Well, this tells us that our answer is basically pi over 6 less than pi. And translating that into degrees, that's 30 degrees less than 180. And so when we go to draw our picture, we could think of this as, okay, we know that 180 would be like straight across. So what would it look like to be 30 degrees less than 180? Well, it would look like exactly what we drew here, right? So either of these methods works. I think the first one is a little easier. I think it's actually great if you can kind of see the number 5 pi over 6 and see it both ways, because that will really help you, again, develop this fluency with what these angles are referring to. Okay, let's do another one. So next we have 5 pi over 4. So I want to think about this kind of using both of those methods that we talked about above. So if you didn't already on the first one, I recommend pausing the video and trying to kind of work through this the same way that we did the one up here. Okay, so first method would be thinking about 5 pi over 4 as 5 times pi over 4. And again, from here, we could actually go ahead and just draw our angle. We don't even need to convert it to degrees. We can just go through and say 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. But let's just convert it to degrees just so that we have both. So we know that pi over 4, that is equal to 45 degrees, right? Because it's 1/4 of 180. So 1/4 of 180 is 45 degrees. And so if you were to multiply together 5 times 45, this one maybe isn't as easy to do in your head, but that is 225. But yeah, I think just from the fact of knowing that's 5 pi over 4, again, that can really help us draw our angle, because we can go like this. We can say, okay, pi over 4 would be 45. 2 times pi over 4 would put us at 90. 3 times pi over 4, that would be 135. 4 times pi over 4, that would put us at 180, and that means that 5 pi over 4 is this angle down here. So just counting off 1, 2, 3, 4, 5. And so 5 times pi over 4 is going to be this angle down here. And if we were to draw this, we would go like this, right? We would say 5 pi over 4. So how could we think of this kind of more like the second method that I wrote out? Well, in this case, it's actually more than pi, right? So 5 pi over 4 can be thought of as 5/4 of pi. So what is 5/4? Well, that is 1 1/4, right? It's more than 1. And so that means that we could write this as pi plus pi over 4, right? It's 1 1/4 pi. So that would be like pi plus pi over 4. You can see that by making a common denominator, right? 4 pi over 4 plus pi over 4 would give you 5 pi over 4. And so what that tells us is that it is pi over 4 more than pi. And in degrees, that would mean it's 45 degrees more than 180. And so, that could actually get you to your picture a little bit faster, right? Because rather than counting out 1, 2, 3, 4, 5 pi over 4s, you could just say, okay, I know where 180 is, and I know this one should be 45 degrees further. All right, let's do one more. So negative 2 pi over 3. So again, I encourage you to pause the video and try this yourself first. So negative, we know that we're measuring it in the clockwise direction. We can kind of drop the negative sign while trying to figure out what the angle is, and then just kind of remember it when it comes to direction. So this one, I actually think, well, actually, we'll do it both ways. I think this one's going to be a lot easier using that first method than the second method, but I think it might be worth doing both of them. So the first method, again, remember, is, and let's forget about the negative sign, like I said. So 2 pi over 3 would be equal to 2 times pi over 3. And if you know your building blocks, you know that pi over 3 is 60 degrees, right? So this is 2 times 60 degrees, and 2 times 60 is 120. However, when we go and actually draw this, we have to go in the negative direction, right? So when we graph this, we can think of it as doing a 60-degree angle and another 60 60-degree angle to put us at 120. You can also think of 120 as being 90 plus 30, right? But we want to go this time in the clockwise direction. So if we were just doing negative pi over 3, that would look like this. I probably made that a little too much. Let's say more like this. That would be 1 times negative pi over 3. And then we add in another 1, and that puts us here. And so negative pi over 3 is going to look like this. Or sorry, negative 2 pi over 3 is what we were graphing. So negative 2 pi over 3 would be this angle. Just to kind of go through doing it the other way, we could also think of 2 pi over 3 as being 2/3 of pi, right? So 2/3 of a number is like 1/3 less than the number, right? It's like you're missing 1/3. And so if you're missing 1/3 of pi, well, that's the same thing as pi minus pi over 3. 3 pi over 3 minus pi over 3 gives you 2 pi over 3. And so we can think of this as pi over 3 less than pi, which is the same thing as 60 degrees less than 180. And so 60 degrees less than 180 would be 120. And again, we're doing it negative, so it'd be negative 120. And that's exactly what we drew here. So I know that you might look at these two methods and be like, I think it's a lot easier just to use that conversion factor. I think it's a lot easier just to always know this rule. I just multiply by this and that's how I get my answer. That is fine, but I just really, really think it's going to benefit you quite a bit if you can get to the point where you're thinking of angles more like this, where you're kind of taking these radian angles and breaking them down into pieces and thinking of them in terms of these building blocks. If nothing else, you definitely want to kind of have these committed to memory, or at least be able to really quickly come up with them. Okay, so next up, we're going to talk about something that I mentioned a little bit in our last video. So it's something called coterminal angles. So to get us to think about this topic, I want you to pause the video and I want you to sketch the angles. So we're going back to degrees for a second. We'll also be talking about radians here, but I want to start with degrees. So I want you to sketch the angles 30 degrees, 390 degrees, and negative 330 degrees in standard position. So pause the video and do that yourself, because I think if you do it yourself, you're going to get a lot more out of this kind of explanation. I'm just going to color code this. Okay, so let's go ahead and sketch these. So 30 degrees, that would mean, so that would look like somewhere like here, right? And so that would mean that we're starting at our x-axis and rotating 30 degrees this way. Okay, so what would 390 degrees look like? Well, 390 degrees is like 360 plus 30, right? So that would be going all the way around. And then, or sorry, I said 30 plus 60, or I said 360 plus 60. I think I meant to say 360 plus 30. Right, so 390 would be starting at your x-axis, going all the way around for 360, and then continuing for an additional 30. And so that would be this angle here. So notice that it ends up at the same place as we did for 30. Okay, what about negative 330? So negative 330, we're now measuring the opposite direction. So negative 360 would be if we went all the way around like this, right? That would be negative 360, and that would we wouldn't really draw anything. It would just be the x-axis. But negative 330, that's not quite as far as negative 360. That would be all the way almost up to the x-axis, but 30 degrees shy. And so that would look like this. So you might look at these three angles and say, oh, they're all the same angle, right? They look the same in this picture. They all kind of land at the same place. However, these are not the same angle. They are what are called coterminal angles. So these three angles all have the same terminal side. So remember again, terminal side just is like the line segment or the ray that you're drawing on the XY plane, they all share that same ray, right? Like you draw them and they all kind of have that same ending point. However, it is not correct to say that they are the same angle. And really the reason for that, so the reason you don't want to think of them as the same angle is because, again, think of an angle as representing rotation. And so these three angles, even though they end up at the same place, they represent a different rotation. And I wish I was in an in-person class because I would literally be turning around in front of the class to demonstrate this. You know, the 30 degree would be like you're just turning a little bit in the counterclockwise direction. The 390 would be you spin all the way around 360 and then you do an extra 30, you end up facing the same way. Negative 330 would be like you spin around the opposite direction and again, you end up facing the same way. So in all three cases, you're facing the same way, but the rotation you did was actually different. So what these angles are called is coterminal angles. And they're called that because they share the same terminal side, right? So coterminal, same terminal side. So we're now going to kind of focus on coterminal angles in general. So in general, if two different angles have the same same terminal side, they are called coterminal angles. So one thing that that will be useful to know, so again, we're going to start by talking in degrees and then we're going to move in radians. I just think degrees are probably still a little bit more intuitive for you, and this is a slightly tricky concept, so I think it's better to start with degrees. So looking at our examples, let's look at the 30 degree and the 390 degree. So what is the relationship between those angles? Well, 30 degrees plus 360 is 390. And you could add another 360 to that, right? That would give you what, 750? 390 plus 360, that would give you 750. That would be, again, another coterminal angle, right? It would just be spinning around twice and then coming back to this 30 degree angle. So in general, if theta, so remember theta is our Greek letter to represent an angle, is an angle measured in degrees, then if you take the angle theta and you add 360 degrees times k, and I'll explain what k means in a second, is coterminal with theta for any integer. So an integer is a whole number, positive or negative, k. So all this is saying is basically if you have an angle, so let's say you have the angle 30 degrees like we did, you can take 30 and you can add any multiple of 360 to that angle, and that will give you a coterminal angle. So let me just write down a couple of things here. So integer just means a whole number, but it can also be negative. So it could be like 2, it could be -5, just not a fraction. So the way I want you to kind of think about this, of this 360k, think of this as just meaning any multiple of 360, so positive or negative. And the way you can think of those things is that you're basically taking your original angle and adding just full rotations either in the clockwise or counterclockwise direction. And so what that's going to do is give you an angle that is different from your original angle, but ends up in the same place because all you're adding in is a rotation, a full rotation around in a circle. So notice that, like we said a moment ago, 390, that's 30 plus 360 times 1, right? That's like adding one rotation. And then negative 330, that would be 30 degrees minus 360, right? 30 minus 360 would be negative 330. And so those are both examples of adding or subtracting a multiple of 360 to your original angle. So let's do an example with this. Let's find 3 different angles that are coterminal with 41 degrees. And feel free to pause this and do this one yourself. There's going to be many different possible answers we could give here, but we'll do a few. Let's try to find maybe at least one that is a negative angle just to make things interesting. Okay, let's start with maybe the simplest one. So one angle we could think about is if we take 41 degrees and we just add 360, right? That's probably like the simplest one. So that would give us 401 degrees. So let's try to sketch these, although 41 degrees is not like a super nice angle, but we know it's just a little less than 45. So maybe something like that. I don't know, it looks like more than 45. Something like that. So let's say that this original one, this is 41. So 401, that would be like going all the way around like this and then back to that 41. So that's 401. So maybe now let's try to do a negative angle. So our negative angle could be, we could subtract 360. We could subtract also 2 times 360. We could subtract 3 times 360. We can subtract or add as many multiples of 360 as we want. Maybe let's just do 1 times 360 to keep things simple. So 41 minus 360, that would be negative 319 degrees. So what would that look like? Well, that would look like going like this. This would be negative 319 degrees. So it's like starting at the same initial side on the x-axis and going the opposite direction and just landing 41 degrees shy of 360. Let's do one more. So this one, let's go big. Let's do 41 degrees plus 5 times 360. So that would equal, if you type this into a calculator, you'll find it's 1,841 degrees. So I'm not going to really attempt to draw this. Maybe I'll draw it and then erase it because it'll just make the picture look kind of confusing, or I don't know, maybe I'll try. But basically this would look like going around 5 times. So 1, 2, 3, 4, 5, and then going that extra little bit for 41 degrees. So that is 1,841 degrees. Again, I wish I was in person because I would just spin around 5 times to kind of demonstrate this to you. So that's with degrees. So with degrees, to find a coterminal angle, you just add any multiple positive or negative of 360. So of course there's a equivalent thing that we can do with radians, right? So this again was for degrees. So now we can say that if theta is any angle measured in radians, so what would be the equivalent thing? If we just said above that that we can take theta and add or subtract any multiple of 360, what is the equivalent thing in radians? Well, 360 is equal to 2 pi radians, right? So we can say here, theta plus 2 pi times k is coterminal with theta for any integer k. So I defined integer above, right? That was a whole number, positive or negative. So again, just looking at this, I want you to look at this and don't see, I think it's very easy to look at this and say, there's so many symbols here, I don't know what's going on. Let's kind of break this apart. Theta is the original angle, right? 2 pi is just a radian measure that represents 360 degrees. And then k, again, just means a positive or negative whole number. And so you can think of this as just being any multiple of 2 pi, positive or negative. So it's the same idea as what we did above. It's just saying we can add extra rotations to our angle in either direction, positive or negative, and we'll end up with an angle that looks the same as our original angle, that is coterminal. So let's do the same thing that we did with the earlier example, but now using radians. So this time we want to find 3 different angles that are coterminal with pi over 4. So I would recommend pausing the video and trying to do this yourself. And again, let's try to do at least one that is negative, just to make things interesting. So again, your answers might vary here. I'm going to start by doing a couple of simple ones. So pi over 4, the first coterminal angle that we might think of is just adding 2 pi. So that's like just adding 360. So how would you rewrite this kind of nicer in radians? So this is something that you're going to want to get comfortable with. Adding and subtracting radian measures that involve fractions is just like adding and subtracting any fraction. You can just make a common denominator. So pi over 4 plus, if we make a common denominator, this becomes 8 pi over 4. And so pi plus 8 pi is 9 pi, and so we end up with 9 pi over 4. So 9 pi over 4 is an example of an angle that is coterminal with pi over 4. So let's sketch both of those. So pi over 4 would look like this. So pretty similar to 41 degrees from the last problem. 9 pi over 4 would mean that we're going all the way around, and then we're going an extra pi over 4. And so that is 9 pi over 4, coterminal. Then let's do a negative one. So let's do pi over 4 minus 2 pi. Maybe let's make it a little more interesting. Let's do minus 4 pi. So again, let's make a common denominator. Pi over 4 minus, so if you make a common denominator of 4, this would be 16 pi over 4. And so that's going to give us negative 15 pi over 4. So what would this angle look like when we graph it? Well, basically it would be, so negative 4 pi would be like 2 directions or 2 rotations in the clockwise direction, right? Because it's negative. But we don't want to do that full 2 rotations in the negative direction because we also have a positive 4 pi pi over 4 being added in. And so we go like this. So we go first, we do 1 full rotation in the negative direction. So that would be negative 2 pi. Then we keep going, but we stop just short of doing another full rotation because we're adding in that positive pi over 4. It kind of counteracts, right? Like the negative 4 pi is in the negative direction, the positive pi over 4 is in the positive direction, so it kind of cancels out that little bit of rotation and keeps it from going all the way around. So this would be negative 15 pi over 4. All right, let's do one more. Again, let's go big on this one. So let's say we wanted to do pi over 4 plus, let's do 3 full rotations. So that would be 6 pi, right? 6 pi means it would be 3 times 2 pi, so that's like 3 extra rotations. So let's make a common denominator again. So we would have pi over 4 plus 24 pi over 4 if we make our common denominator. And so that gives us 25 pi over 4. And so this angle would be now going again in the counterclockwise direction. This would go around 3 times. So that would be 2 pi, 4 pi, 6 pi. And then we go that little extra bit to get the extra pi over 4. So that would be our angle of 25 pi over 4. And I know these pictures are kind of hard to look at once we get everything on there, but I still think it's good to go through the motions of drawing it so that you just kind of can make sure you really understand this rotation idea. All right, one last example in this video. This is gonna kind of ask us to work backwards. So this is actually a pretty common thing that you wanna be able to know how to do in this class is if you're given a very large angle, you might wanna be able to figure out, what is a kind of more normal, easy to work with angle that is coterminal with this angle. So in other words, we want to find an angle between 0 and 2 pi, because those are kind of the nice ones, right? That's like just between 0 and 360. Those are kind of like the most normal seeming angles you can think of. So we want to find an angle in that range that is coterminal with 25 pi over 3. So how can we do this? So one way that we can do this is we can just kind of subtract out subtract out 2 pi, right? Because 2 pi is 360. And we can keep subtracting out 2 pi until we're left with an angle that is in the range that we're looking for, right? Because we know that anytime you add or subtract 2 pi, you end up with an angle that is coterminal to your angle. And so if we just keep subtracting out 2 pi, we're going to keep getting these coterminal angles. And if we do it until we get an angle between 0 and 2 pi, then we can actually answer this question. So we're going to have to do it a good number of times. And of course, there's faster ways to do this. If you can kind of in your head figure out how many multiples of 2 pi to subtract, you can kind of jump straight to that. But I think most of us can't look at this and immediately figure out how many copies of 2 pi to subtract out. So we can just kind of do it one by one. Okay, so if we subtract out 2 pi once, that's 25 pi over 3 minus, make a common denominator, that would be 6 pi over 3, right? And so we're left with 19 pi over 3. So 19 pi over 3 is coterminal with 25 pi over 3. However, 19 pi over 3 is not between 0 and 2 pi. How do you know? Well, basically, again, think of 19 pi over 3, that's the same thing as 19 thirds times pi. And 19 thirds is a lot bigger than 2, right? 19 over 3, that's like a little more than 8. So that's definitely, a little more than 6. So it's definitely bigger than 2 pi. So let's do it again. So we can find another coterminal angle by taking 19 pi over 3 and subtracting out 2 pi again. So make a common denominator once again. And so this time after the subtraction, we're left with 13 pi over 3. So that is once again coterminal. Now again, we want to check, is this between 0 and 2 pi? And so the way that we can check this is again by thinking of it as 13 over 3 times pi. So we need to ask ourselves, is 13 over 3 bigger or smaller than 2 pi? Bigger or smaller than 2? It's bigger, right? 13 divided by 3 is a little bit more than 4. And so we're definitely still too big. So we can do it again. We can subtract out 2 pi again. So this will give us now 13 pi over 3 again minus 6 pi over 3. And so this time we're left with 7 pi over 3. And this is starting to feel like it might be between 0 and 2 pi, right? But it's actually not, because again, using that same kind of idea, thinking of this as 7 thirds times pi, 7 over 3 is still more than 2, right? So 7 thirds pi is still more than 2 pi. And so we still have to do this one more time. Oops, sorry. This should be 7 pi over 3. So now we're subtracting out 2 pi. So we have 7 pi over 3 minus 6 pi over 3. And that's going to leave us with pi over 3. And that is definitely between 0 and 2 pi, right? So basically what we did is we actually in this process found 4 different angles that are all coterminal with 25 pi over 3, but pi over 3 is the one that's between 0 and 2 pi. And you might notice, if you wanted to kind of figure out like how could you maybe have gotten to this answer quicker, well, how many times did we end up subtracting out pi or 2 pi? We subtracted out 2 pi 4 times. So really what we did is we subtracted out 8 pi, right? 4 times 2 pi is 8 pi. And so we can see that if we write this down as 25 pi over 3 minus 8 pi, that would be 25 pi over 3 minus 24 pi over 3, making a common denominator. And that is equal to pi over 3. So that's kind of a check we can do to see, okay, that makes sense. We subtracted out 2 pi 4 times. That's the same as subtracting 8 pi, and that gives us the same thing, pi over 3. All right, so that is it for this video. Like I said, this stuff we're going to be using quite a bit in this class, so I would really recommend taking some extra time to just really practice getting comfortable with radians, getting comfortable with the idea of coterminal angles, because it will really serve you well later on in the quarter. So I'll see you all in our next video.